Assalamualaikum warahmatullahi wabarakatuh. Let me introduce myself. My name is Winandita Amelia Douryat with NIM K1323089. Today I want to explain about transformation. Transformation is divided into four. There are reflection, translation, rotation, and dilation. But at this moment, I want to explain two of them. There are rotation and dilation. Okay, next. What is rotation? Mathematical rotation is the movement of a point on a geometric plane by rotating it at an angle A to a certain point. The rotation of these points can be clockwise or anticlockwise. That's why, when rotating, the corner sign agreement applies. The rotation angle will have a negative sign if the direction of rotation of the point is clockwise. Conversely, the rotation angle will have a positive sign if the direction of rotation of the point is opposite to the rotation of the needle clock. Okay, next. Factors affecting mathematical rotation. There are three factors. The first is center point of rotation. The center of rotation is a point that serves as a reference for rotational movement from the start point to the end point. The center point of rotation is divided into two, namely point 0, and point A, point B. The second is a large rotation angle. In translation, the rotation angle can be analogous to the amount of displacement of a shape or point. The size of the rotation of a shape or point is influenced by the size of the rotation angle. The third, direction of rotation. The direction of rotation indicates the direction of rotation of the point or shape. The direction of rotation affects the signs of the rotation angle. Next, types of mathematical rotation. Based on the center point, mathematical rotation is divided into two, namely rotation about the center point 0, and rotation about the center point A, point B. So, what's the difference between the two? The first, rotation about the center point 0. Rotation can be symbolized as R, P point A. That is rotation with the center point P, a distance A. Second, rotation about center point A, point B. The rotation does not have to be centered at the point 0, but can also be centered at the point A, point B. The next, the formula of rotation. Number 1, center point A, point B, x, point y. For rotation 90 degrees with center A, point B, x, point y is minus y plus A plus B, point x minus A plus B. For rotation 180 degrees with center A, point B, x, point y is minus x minus 2a, point minus y plus 2b. For rotation of minus 90 degrees with center A, point B, x, point y is y minus b plus a, point minus x plus a plus b. Number 2, for center point 0, 0, x, point y. For rotation of 90 degrees with center 0, 0, x, point y is minus y, point x. For rotation 180 degrees with center 0, 0, x, point y is minus x, point minus y. For rotation of minus 90 degrees with center 0, 0, x, point y is y, point minus x. Yet the next example of a rotation type geometric transformation problem. For number 1, a point A, 3.2, is rotated about point O, 0.0 by 90 degrees clockwise. Determine the image of point A. Answer: A, x, point y equal 3.2. A, x, point y equal y, point minus x. So we get minus 2.3. For example, number 2, point P, 3 point minus 4, is rotated 90 degrees clockwise at the center O, 0.0, then rotated again 180 degrees clockwise at the center O, 0.0, producing an image P. So the coordinate point P is, answer, P x point y equal 3 point minus 4. P x point y minus 8 minus 90 equal y point minus x. So we get minus 4 point minus 3. P x point y for 180 is equal minus x point minus y. So we get 4.3. Okay, for the second topic is dilation. What is a dilation? Dilation is a change in the point of an object in the geometric field based on the value of the multiplying factor. In this type of transformation, the size of the shadow can be different from the size of the shadow being fixed. However, the shape remains the same. Why is that? This is because there is a multiplying factor. For example, if an object is magnified by a multiplier equal to, then the image of the object has a size of 2 times the size of the initial object, and the distance of the image from the center point is also twice the thing. However, it could also be sized farther than the distance of the object and the center point at first. Okay, next, multiplier factors in dilation. The multiplying factor is the determining factor, the location and size of an object resulting from dilation. So, what is the relationship between dilation and the multiplying factor? Okay, the first, a multiplier factor greater than 1 or k greater than 1 will result in an increase in the size of the object and is in the same direction as the dilation angle initial object. Number 2, a multiplier equal to 1 or k equal to 1 does not result in a change in the size of position of the object. Number 3, a multiplier between 0 and 1 or 0 is smaller than k and k is smaller than 1 results in a reduction in the size of the object and in the direction of the initial dilation angle. Number 4. Multiplier factor between minus 1 and 0. Minus 1 is smaller than k and k smaller than 0. Results in a reduction in the size of the object and has a direction opposite to the initial dilation angle. Number 5. A multiplier equal to minus 1 or k equal to minus 1 does not result in a change in the size of the object, but the direction is opposite to the initial dilation angle. Number 6. A multiplier factor smaller than minus 1 or k smaller than minus 1 results in an increase in the size of the object and has a direction opposite to the initial dilation angle. The next types of dilation. Based on the center point, dilation is divided into two, namely dilation to the center point 0.0 and dilation to the center point A, point B. What is the difference between the two? The first, dilation to the center point 0.0. The general form of dilation of point A to the center point 0.0 can be expressed as follows. The formula is like this. The writing from above shows that point A with coordinate x, point y is dilated towards the central point 0.0 with a multiplier factor k, resulting in point A with coordinates x, point y. So, you can determine the coordinate x, point y using the matrix equation as below. Okay, the second is dilation to the center point A, point B. If point A experiences dilation towards the center point A, point B with the multiplier factor k, then mathematically it can be expressed as like this. Then, how do you determine the final coordinates of the dilation? The final coordinates can be found with the following matrix equation. Example of a dilation problem. A rectangular object PQRS is in the Cartesian coordinate plane as follows. If the object is dilated about the center point with k equal to, determine the shape of the image that occurs. The solution? First, determine the coordinate of point P, point Q, point R, and point S as in the table. Next, determine the coordinates of point P, point Q, point R, and point S using the dilation equation about the center point. We can use the formula for find the point P, Q, R, and S. Like this, so we get P 2.6, we get Q 8.6, we get R 2.4, and S 8.4. Obtained like the table. If depicted in Cartesian coordinates, it becomes like the picture. Okay, thank you.